Assalamualaikum everybody, welcome to this week's lab. This week we are going to use your IoT kit that has been given by the faculty to make a simple digital output program. In order to make it easier for you to see the connections for the circuit, I use the Tinkercad simulator that is available on the internet. However, the simulator doesn't have the NodeMCU just like you have in the IoT kit. So what I'm going to do is I'm going to use the Arduino Uno in the simulator to show you the connection. The location of the pins for the Arduino Uno and the NodeMCU is different. What I'm going to do is to use the same number of the pins on the Arduino Uno, and you have to connect with the NodeMCU on the same pin as instructed. For example, if I connect the jumper wires to number 2 on the Arduino Uno, you have to connect to the D2 on the NodeMCU. There are also some other differences on the pins. For example, on Arduino Uno we have 5 volt, but there's no 5 volt on NodeMCU. And another one is on the Arduino Uno is going to show 3.3V. However, on NodeMCU it will be tagged as 3V3. First and foremost, we have to connect the 3V3 pins on the NodeMCU onto the red line on the breadboard. Next, we are going to connect the GND on the NodeMCU to the black wire on the breadboard. The best practice for the connection is to use a red colored jumper wire for the 3V3 and use the black colored jumper wire for the ground. Next, take an LED from your IoT kit. It can be any colors that you like. Make sure the cathode of the LED is put on the E20 while the anode of the LED is on E21. As a reminder, the cathode is usually the one with the shorter leg than the anode. Another method to see whether it's cathode or anode is by looking inside the LED. The ones that is holding the flag is the cathode. Next, we are going to put a resistor onto the circuit. The resistor we are going to use is the 220 ohm. The reason we are putting the resistor here is to avoid any overcurrent that might break the LED. Put one pin of the resistor on D21 and another one on D25. There are no polarities for the resistor, so you can put it any order. Next, we are going to connect the signal wire from D2. Use an orange colored wire and connect it to A25. This will connect the D2 from the NodeMCU to the resistor and will be connected to the anode on the LED. Next, we are going to connect the ground to the cathode of the LED in order to make it a complete circuit. Once you have connected all the components as shown in the diagram, now it's time for you to open the Arduino IDE on your computer. We start by declaring the LED pins to be on the number 2. And then we are going to set the LED pin to be an output. Now go to the loop function and make the LED to give an output of high. Verify your coding by clicking the tick button on the top left of Arduino IDE. If there is no error on the compilation, just upload the coding to the NodeMCU. Observe the LED whether it's turned on or not. According to the coding that we written, it should be turned on all the time. Next, we are going to put a little bit more coding on the loop function. We are going to set the LED to high and then delay it for 1 second, and then set it to low and delay it for 1 second. As you know, the loop function will loop indefinitely until the battery runs out. So what will happen is the LED will be blinking on and off until there's no more battery or power coming into the NodeMCU. So you need to go to the verify on the Arduino IDE and verify your code. If there's no error, just upload the code on the NodeMCU using the upload button. You should observe that the LED is turned on and off in 1 second interval. You should also observe that there's a blue LED on top of the NodeMCU. It should be blinking at the same time as the LED that you put on the breadboard. Congratulations, now you've mastered this task. So now we are going to put another 2 LEDs on top of the breadboard. Place it anywhere you like on the breadboard. Just make sure that the LED cathode is connected to the ground and the anode is connected to a resistor of 220 ohm, and then the resistor will be connected to the signal that is going to come out. The signal pins that we're going to use is the D4 and D5. Again, the best practice to connect the ground wire is by using a black colored wire. The signal wires can be in any color. For this example, I use orange, yellow and green. Once you finish connecting the circuit, now we'll go to Arduino IDE to make some coding to put on the NodeMCU. First of all, we are going to declare 3 LED pins. We number it as LED pin 0, LED pin 1 and LED pin 2. Put 2, 4, 5 according to the pins that have been connected to the breadboard on NodeMCU. We should also set the pins as output. Now add another 4 lines in the loop function. Make all the LED turn on and off at the same time. With this connection and this coding, all LED will turn on at the same time. Wait for 1 second and it turn off, and wait for 1 second before starting the loop again. Verify your code, and if there's no error on the code, so you should upload it on your NodeMCU. Once the upload is finished, observe the LEDs on the breadboard. Try to change the high and lows on the LED and observe what will happen on the LEDs on the breadboard. I think that's all for this week's laboratory. I hope you understand how the connection and the circuit works, and I hope that you understand how to program digital output for the NodeMCU. That's all for now. Thank you very much.